Hello, this is Dr. Oz. Today, I would like to talk about inventory management. In supply chain management, inventories are very important. Although we do not want to have inventories in general, the reason is that the more inventory that we have, it will cost us more money because we tie our capital to the inventory, and basically when opportunity costs, we could invest that money to another investment option, and that could generate us money. So we are losing that money. And also these items could be perishables and we may lose them, and there may be some kind of time may impact quality of the products and so on. So inventories in general, they are not good. However, companies do have inventories. The reason is that supply and demand for a company in general, they are not the same. They fluctuate, especially demand fluctuates a lot depending on the type of product. So if you have high demand and if you don't have inventory, basically we will lose sales, right? And if the inventory is, if the demand is way too low, if we just keep producing or buying the items, then we would create a huge inventory that will cost us so much money. So here in this module, I would like to talk about the importance of inventory management and show you some of the inventory management models. So let's create an Excel file to talk about inventory management. So I'll call this Excel file as inventory management. Right, so let's open our Excel file and start building our model. All right, as you know, I like to start my model with given information. So let's work on an example with given information. So in this section, I will put the name, the value, and the unit of these parameters. So the first thing in this example we have is the demand. Okay. So we have demand, but we don't really know what the demand is. Based on historical data, we figure out that the demand is behaving as a discrete uniform distribution. Discrete uniform distribution. And discrete uniform distribution has basically two parameters. One of them is minimum demand, and the other one is maximum demand. Basically, you look at the historical data and you identify minimum and maximum demand. So minimum demand is 10 purses per day. And maximum demand, we assume that is going to be 30 purses per day. So we are selling purses. Okay. So this is not the parameter of this discrete uniform distribution, but let's put here also average demand, which is average of 10 and 30 would give us 20 purses per day. All right. So discrete uniform distribution is going to create a number between 10 and 30. These are integer values with equal probability. So it could be 10, 11, 12, all the way up to 30 per day. So another important thing in this inventory model is that to know average holding cost. Average holding cost. Okay. So average holding cost is given as $100 per year, per purse per year. So this means that if I keep a purse in my inventory for entire year, it would cost me $100. Why? Again, I could spend that money for another project that I have in my company, or invest in stocks, or mutual funds, or bonds, and generate money out of it. So there is some kind of opportunity cost, and we quantify here that value is $100 per year. Another thing that we need to know in this model is the beginning inventory. At time 0, how much inventory do I have? So it's given that we have 200 purses to begin with. And we need to also know ordering cost. So ordering cost is given here in this model as $200 per order. So there is a trade-off in this inventory model between the holding costs and ordering costs, because the more inventory that I have, the more holding costs I will have, but less ordering costs I will have. The reason is that I can order big quantities, let's say whole year supply, and I will order only once a year, but then that will boost my holding costs negatively. On the other hand, if I order, let's say, every single day, basically my holding costs will be very minimal because I don't have inventory, but then I will have huge ordering costs because I order every single day. Another thing that is important in inventory models is that reorder point. ROP. So reorder point is the point where we decide to order something. Let's say at our place, right, we have reorder point for toilet papers. Basically, you don't wait for until the last roll, because if you do that, you may have some problem, right? When you go to the restroom, you may be in trouble. So that's why, let's say, your reorder point could be 3 rolls. Whenever you have 3 rolls, you go to Amazon, and it will take a day or 2 to be delivered. Those rolls, toilet paper rolls. So that's why, as you can see from this example, it is important to know the lead time and then demand too. So if I use 1 roll per day, and if it takes 3 days for Amazon to deliver my products, so I'd rather put my reorder point as 3, because from the point where I ordered, from the time it's delivered, it will take 3 days, which I need 3 rolls in the meantime. So the reorder point in this problem is 100 purses. So if you want to know how I calculate this, this is how I calculate it. So I know my lead time. So lead time, as we talked about, times demand. So I know my lead time, let's say it is 5 days. It takes 5 days for me to get that product. And the demand per day on average is 20. So my reorder point is 100 units. Whenever I have 100 units in my inventory, I trigger for a new set of inventory. And the model duration is important as well. Model duration. So in this case, my model duration is 365 days. So I build this model for 365 days. Okay. So this is it for now in terms of given information. And the next thing I would like to do is, of course, build my model. I will build my model. So in this model, first thing I would like to ask, like in any model, what is my objective? So my objective is, in this case, I have a bunch of costs here, ordering costs and holding costs. So I don't have any revenue information given to me. And so I would like to minimize the bad things. So I would like to minimize the total cost. But to be able to minimize total cost, I need to measure. So in this problem, I have 2 different types of costs given, if you look at the given section, which are ordering cost plus holding cost, right? So if I add these 2 costs up, that will give me my objective, which is minimize the cost. All right, that's good. So now, next thing I would like to know, of course, is that what is ordering cost and what is holding cost. So I need to calculate those as well. So let me just maybe green cell here. I know this is gonna be my objective. And let's focus on ordering cost. How would I calculate the ordering cost? So ordering cost is gonna be number of orders per year times unit ordering cost. Unit ordering cost. Of course, like if I order 5 times and each of them cost me $10, 5 times 10, $50. All right. So I will calculate my ordering cost right here. And also I need to calculate my holding cost. Holding cost is equal to number of inventory, number of items in my inventory times, I can say each day on average, times holding cost per day. Holding cost per day. Of course, the more inventory I have, the more holding costs I will have, right? So this is how I'm gonna calculate. All right, so that's it for today. In next video, I would like to build my model step by step and conduct my scenario analysis and to see the best order quantity, and then I will visualize my graph. Until next video, enjoy supply chain management.